Hello students, today we are going to be covering angle bisectors. So this relates pretty heavily to the angle addition postulate because yesterday we looked at how two smaller angles form together to make one larger angle. And today it's going to be pretty much the same idea of dealing with two smaller angles making a bigger angle with the added special property of a bisector, meaning that there's two little angles formed are going to be perfectly equal in measure. So let me flip ahead to page 10. We're also now finally in September. My goodness, how time flies. So we say a ray bisects, oops, making mistakes already, bisects an angle if it splits the angle into two smaller angles of equal measure. So bisects is an important word for today. And breaking the word down, bi means two and sect means split. So split in two. And it's not just split into two, but split into two equal parts. So two angles of equal measure. And everything is better with a picture to explain it. So if ray BD bisects angle ABD, or ABC, then that means that the two angles formed are going to be the same measure. So we might say ray BD bisects angle ABC. And because this ray is cutting angle ABC into two equal pieces, that means that the measure of angle ABD in red here is equal to the measure of angle DBC, with that one being in blue. I'm picking the wrong side of my marker to open up. So anytime you have any angle bisected, the two formed will always be equal. So let's take a look at a few simple examples. So I'm going to draw a bisected angle here. Label it J, L, N, and M. So these markings here mean that the angle is bisected and these two are congruent. The measure of angle JLM is 26 degrees. Then what is the measure of angle MLN. Well, if ray LM is bisecting angle JLN, and one's half is 26, then the other half has also got to be 26. So what about the measure of angle JLN? That's the big one. Well, if I said half of a pizza is 4 slices, how many slices is a whole pizza? Hopefully we recognize, well, if 4 is half, then another 4 would make a total of 8 slices, and that would be my whole pizza. So what you did is you multiplied 4 times 2 to get your whole. You do the same thing here. 26 times 2 is 52 degrees. And that's that angle addition postulate at work, because if this is 26 and this is 26, then the whole thing has got to be 52. Let's take a look at another one. So we're going to start out with a straight angle. And I'm going to bisect it. Now, just by looking at this, we might already have an idea of how this is working out. So if the measure of angle PQR is 180 degrees, and ray QS bisects angle PQR, what is the measure of angle PQS? Well, if this whole thing is 180 degrees and I have cut it in half, all you have to do is take that 180 and divide it into 2 equal pieces. And that tells you, hey, this is broken up into 2 right angles. If it asked me for SQR, it would be the exact same thing because these are both now the same measure, 90 and 90. So this is geometry's convoluted way of asking you to multiply by 2 or divide by 2. Sorry, had to cancel something. All right, so let's start getting into the algebra side of things. I'm going to start with an obtuse looking angle, ABC. D. This angle is 34 degrees, and this angle is x minus 7 degrees. Ray BD bisects angle ABC. Now we always want to make sure that the problem is telling us in one way or another that it is being bisected. Otherwise, we can't assume that the 2 halves are going to be equal. But if it tells us they're being bisected, then we can know for sure that the 2 are being bisected and the 2 are equal. And so in that case, we can set up blank equals blank. Just like up here, one half equals the other half. That's how we're setting up our equations here. So I know I haven't been using a lot of colors lately, but I'm doing my best to catch up, so I'm being a little more plain in my notes. So 34 equals x minus 7. And then all we have to do is solve that equation. Add 7 to both sides. And we get 41 equals x. And we can check if I do 41 minus 7, I should get 34. These two should be equal. And that's all you have to do is set the two sides equal to each other, and you're good to go. Let's do one last example for today. H, I, J, and K. So ray IK bisects angle HIJ. The measure of angle HJK equals 7x minus 11. And the measure of angle K Sorry, I wrote things a little bit differently in my other thing I notes. I think I messed up. H, that should be I. HIK, measure of angle KIJ. Okay, got myself a little confused. Equals 3x plus 5. So we're saying this angle, 7x minus 11, and this one is 3x plus 5. And based on the fact that the angle is being bisected, I can set these two equal to each other and solve. Again, 7x minus 11 equals 3x plus 5. And now I just have to solve this equation. I'm going to use blue for this since we have a little bit more going on. Since I have a variable on both sides, I'm going to want to move my smaller variable to keep my numbers positive. So I'm going to subtract 3x from both sides. And that'll give me 4x minus 11 equals 5. Now I'm going to add 11 to both sides. That'll give me 4x equals 16. And then from there, I divide both sides by 4 and get x equals 4. So if the problem asked me to solve for x, I would be done at this step. But if it asked me something like, find the measure of angle HIK, I would have to use x equals 4 to figure that out. So let's plug in 7x minus 11. 7 times 4 is 28. And 28 minus 11 is 17. So make sure you're reading the directions and seeing, does it want you to find x, or does it want you to find the actual measure of the angle? Some questions will ask you one and others will ask you the other. All right, that's all I have for angle bisectors. Just remember to set the two halves equal to each other whenever you're solving a problem dealing with angle bisectors. Good luck on your assignment, and if you need anything, reach out to me. Bye.